Okay, welcome to the chapter 2, part 2 video. Here we're going to be talking specifically about linear functions. So we're going to talk about slope, then we're going to define linear functions and talk about some of their properties. We're going to talk about slope-intercept form, and I forgot to add the bullet point here that we're also going to graph. Okay, so let's start out with what is slope. So hopefully this is a little bit familiar. A slope is described, the slope helps describe a line. So it's not used for any function, it's only used for linear functions, for functions that are straight lines. And a slope we can describe as the rise over the run. We're talking about how steep is the line. Is it pointed more up or is it pointed more flat? Is it pointing up to the right or is it pointing down to the right? And so the slope describes kind of the angle or how high or low the line is pointing compared to the x and y axis. So for the slope of a non-vertical line, and it's important that it's non-vertical because remember we talked last class about functions and the vertical line test. And if I have a vertical line, let's say there's my y and x axis, and I have this vertical line, is that a function? No, that's not a function. It doesn't pass the vertical line test, right? So in this case, we're talking about linear functions, so that does not include vertical lines. So the slope of a non-vertical line is the ratio of the vertical change, which we call the rise, to the horizontal change, which is called the run. And we're always looking between 2 points. And you can pick any 2 points on a line. It doesn't have to be the closest 2 points. It doesn't have to be the intercepts or anything like that. It can be any 2 points on the line. Okay, so when we're looking at our definition of slope here, the slope of a non-vertical line through the points x1 comma y1, notice that's the x and the y values, as we were talking about with functions. X is first, y is second. X is our input, y is our output. And our second point, we'll just put the subscripts 2 to say that it's our second point. So we have x2 and y2. So this is our first x, there we go. Our first x, our first y, and then we have, I'll switch colors here, to have our second x and our second y. We need 2 points, which means we have 2 x values and 2 y values. And then we find the ratio, meaning we're going to divide them, of the vertical change. Vertical change, that's up and down, is going to be our y values. So we're taking the difference in our y values. Another way to write that is change in y. That little delta, it's a Greek letter. Delta means change. So when we're saying delta y, that means the change in y divided by the horizontal change, and that is the run. That is our change in x values. Now it's important that if you're going to subtract y2 minus y1, you have to divide it by x2 minus x1. So let me erase this here. The reason it's important to keep those in order, this is one of my points, and I have to subtract the other point, okay? Now, which one I call my first point and which one I call my second point is not as important. But what is important is that you take the first part, the term that you're subtracting from the same point, okay? We'll see an example here. So let's see if we can find the slope of the line that passes through these points. So I've chosen the points and we're going to find the slope. I'm going to do the first one and then I'll have you try the second one and then we'll go over it together and then I'll have you try the third one. Okay, so the first one we'll do together. First thing I'm going to do is I'm going to label my variables. I'm going to call this point 1. So this will be x1 and y1. And then we have our second point over here. I'll call that x2 and y2. Okay, so slope, which we label with a variable m, is change in y over change in x. Or you can say rise over run. I won't write all of this out every time. Okay, so we're going to start with y2 minus y1 divided by x2 minus x1. Now, if you had switched and you called your first one here the second point, and you called this one the first point, you would end up with exactly the same answer. Okay, so it doesn't matter which one you call first, which one you call second. What it matters is that you put them in the same order when you put them in the equation. So y2, that's my green one, is 4, minus y1, that's the red one, is 7, divided by x2 is green, -2, don't drop your negative, minus x1 is a -3. Now notice I have a subtracting of a negative, that changes to addition, right? If I subtract a negative, it changes to addition. So 4 minus 7 is -3, -2 plus 3, -2 plus a +3. So that's the same as 3 minus 2 is 1. Our slope here is -3. Go ahead and try part B. All right, we'll go through this together. Our slope, I'm just going to say m equals our y2 minus y1 divided by x2 minus x1. Now I'm going to intentionally call this point x comes first, x2, y2, and then I'm intentionally going to call this other one x1, y1. Now the reason I'm going to do that is because I think you probably called the first one 0.1 and the second one 0.2, and I want to show you that it doesn't matter which one I call the first and which one I call the second. As long as I put them into the equation correctly, I should get the same answer. Okay, so y2, that's 1, minus y1 is 1, divided by x2 is 3, minus x1 is -4. Subtracting a negative becomes positive. 1 minus 1 is 0. 3 plus 4 is 7. 0 divided by 7 is 0. What does it mean to have a slope of 0? Well, let's look at this graph. If I have 3, 1 and -4, 1, that is a horizontal line. A horizontal line has a slope of 0. Okay. Next, let's look at part C. Go ahead and try that one. Okay, I assume there's probably a mix of you that called the first one 0.1 and a mix of you that called the first point x and y2. So I'm going to go ahead and kind of do the backwards. I think I want to show you that way again. So we have x2, y2. And then this one I'll call x1, y1. And if you did it the other way, that's absolutely okay. To find the slope, I'm subtracting y2 minus y1 divided by x2 minus x1 equals, okay, so y2, that's my -3, minus y1 is 1, divided by x2 is 7, minus x1 is 7. Okay, so here we have -3 minus 1 is -4, divided by 0. Uh-oh. What happens when I divide by 0? I can't. This is undefined. Why is this undefined? Well, let's look at what this graph looks like. Okay, so we have 7, -3, and we have 7, 1. Well, this is a vertical line. A vertical line is not a function. So its slope is undefined. Remember, we said it has to be a non-vertical line in order to find its slope. Okay, let's take a look at our next slide here. Let's summarize slope. Now, hopefully we have kind of a feeling for when we're graphing that the right side is like we progress towards the right, right? Our numbers go from negative to positive. And so if we have a positive slope, that means it's going upward to the right, up to the right. If we have a negative slope, negative we think of down, right? It goes down to the right. So think about uphill, positive, downhill is negative, always going from left to right. As we saw in our last example, if it's a horizontal line, it has a slope of 0. And if it's a vertical line, it has an undefined slope. And so we have this little tool called slope face. And there's different versions of slope face. And it's just kind of a tool that could help you remember which slopes are positive, negative, undefined, and 0. And I find it most useful for undefined and 0. So we have the face. If I have positive slope and negative slope with the eyebrows kind of going on the outside, that reminds me which one's positive, which one's negative. The nose is undefined, and the face with the little cheeks is 0. So vertical lines are undefined and horizontal lines are 0. Okay, so let's see if we can define our linear functions, right? So we define lines as being straight. If it's a linear function, it has to be non-vertical, right? So a function whose graph is a line is a linear function. That's all there is to it. And we can always represent a linear function with a linear equation y equals some number times x plus or minus some number. We say y equals mx plus b, where remember m is our slope. Okay, so the solution to a linear equation is any ordered pair x, y, that's a point, that makes the equation true. We saw this last class, right? If our ordered pair satisfies our equation, if we get a true statement, then that point is on the line, on the equation, okay? An intercept, think about like in football, if you pass the ball but someone else catches it, it's an interception. Intercept means that two things are crossing, okay? And so when we're crossing a line across one of our axes, it's called an intercept. So if it's crossing our x-axis, it's an x-intercept. If it's crossing the y-axis, it's a y-intercept. So our line crossing the axes, those are our intercepts. And that's the special role that b plays. B is the value of the y-intercept. Well, let me try drawing that one again. Of the y-intercept. Okay. Now, why didn't I say that b is the y-intercept? Well, the y-intercept is a point, right? And a point has an ordered pair. In this case, it will be 0, b. So the ordered pair describes the point or the intercept, but b is the value where that intercept occurs. Okay, it's the y value where the graph crosses the axis. So let's look at some examples with our slope and intercept. So we said slope was m, our intercept is b. This is the one that's added, and this is the one that's multiplied. So how do you know which one is your slope? It has to be multiplied to x. If I have an equation such as y equals x plus 2, what is the slope here? Well, there's no number multiplied to x, but remember there's always that invisible 1. So the slope here would be 1. If I have something like y equals 3x, now my slope is 3, I can see my slope, but what is my y-intercept? Well, I can always put plus 0. Remember some of those properties of numbers that we talked about. We have our identities. So 1 is the multiplicative identity, that's why I didn't have to draw it, right? But it's still there. And 0 is our additive identity. Again, I didn't have to draw it, but it's still there. Okay, so let's look at slope-intercept form. Slope-intercept form is an equation where the line is y equals mx plus b. M is the slope. Notice it's multiplied to x. And 0, comma b is the y-intercept. Notice that that is as an ordered pair. That's a very important, not b, but 0, comma b, the ordered pair. So let's find the equation of the line. We know that the slope is 1/5, and we know that the y-intercept is 0, comma -3. So that tells me that b is -3. So our equation of the line y equals mx plus b. Now I can substitute m and b. Y equals 1/5 x. That's okay that it's a fraction. It can stay a fraction. Plus -3. Well, plus -3 should be simplified. I don't want to have two symbols right next to each other. So that is y equals 1/5 x minus 3. Okay. In our next example, we aren't given the slope and the intercept, but we are given a graph. And so we can find the slope and the intercept. Let's start with slope, okay? In order to find the slope, remember this is rise over run. So let's see, from one point to the other, I have to rise 3. I went up by 3. And I have to run backwards, right? I'm running to the left. So I'm running 1 unit backwards, that's a -1. 3 divided by -1 is -3. So our slope is -3. What about our y-intercept? Well, our y-intercept here is at 4, giving us the point 0, comma 4 as our y-intercept. But really all we need is the value of b. b equals 4. So now I can substitute that into my equation. Y equals mx plus b. Y equals, m was -3x plus b is 4. Okay, where m is the slope and b is the value where the line crosses the y-axis. A lot of times we'll say b is the y-intercept. It's not completely accurate. We just have to keep in mind that the y-intercept is a point and should be an ordered pair. All right, let's take a look at our next example here. I'd like you to try these two on your own and then we will go over them together. Okay, so starting with part A, again, we're given m and I can find that b is 5, y equals mx plus b, y equals 6x plus 5. That should be your answer to part A. Part B, okay, so now I need to find the slope. Rise over run. Well, if I start with the lower point, I rise by 1, and then I go over, but I'm going over to the left. So again, that's a negative distance. I go 2 to the left. So that's a -2. So our slope here is -1/2. Now, proper form, we don't want to leave the negative in the denominator. We can take it out front of my fraction, right? So a -1/2 is the same as 1 divided by -2. Or we can even move it into the numerator, -1 divided by 2, but we don't really want to leave that negative in the denominator, okay? I won't mark it wrong, but it's not considered simplified form. So if the instructions say to simplify, then you'll lose partial credit for that. Okay, next we need to find our y-intercept. So I'm looking at my graph. It crosses here at -3. Again, we go to our formula. Y equals mx plus b. Our slope is -1/2 x. B is -3. So notice, as I get used to this equation, I started to skip that step of plus a negative just becomes minus, right? If you're not comfortable with that, put plus -3 and then simplify it. Okay, let's take a look at our next example. Write the equation in slope-intercept form. What are the slope and the y-intercept? So again, we want to write this equation in slope-intercept form. I need to know what slope-intercept form looks like. We want y equals mx plus b. Notice that y is by itself. So in order to write these in slope-intercept form, I need to get y by itself. Now, we've seen something like this, right? We need to solve for y, but there's also an x. That's okay. Just treat x as if it was a number, okay? So if we're looking at our first example, we want to get y by itself. What's preventing it from being by itself right now is that 5x. So if I want to remove the 5x, I want to move it over to the other side of my equation. I need to do something to get rid of 5x. Now, how is it attached to the y? Here, the 5x is attached to the y by subtraction, right? Which is a form of addition. So I want the opposite of 5x, that is negative 5x. Subtracting 5x from both sides, those will cancel out. If I had divided, it would have become 1, but I would still have a 5x in the denominator, right? It doesn't cancel out with the negative 4y. So we have to be careful. If it's attached by addition or subtraction, you're going to add or subtract. If it's attached by multiplication, that's when we divide. So now we have negative 4y, don't drop that negative, equals, now I know the x goes in front of the number, so I'm going to write this as negative 5x plus 16, right? Because my goal is to get it into slope-intercept form. Now what's preventing y from being by itself is that negative 4. How is it attached to y? This time it's being multiplied, so I have to do the opposite of multiplication. This time we can divide. Divide by negative 4, divide everything by negative 4. So that will reduce, and we get y equals, we have a negative divided by a negative. Negative divided by a negative gives us positive 5/4 x. Positive 16 divided by negative 4 is negative. 16 divided by 4 is 4. Okay, go ahead and try, actually we'll do part B together because it has fractions. So whenever our equation has fractions like this, our very first step is going to be to clear the fractions. And what that means is multiply by the number in the denominator that would get rid of all of the fractions. So if I'm looking at these fractions, I could say, well, I have a 4 and a 2. What if I multiply everything by 2? Well, the 4 won't get canceled out, right? But if I have 4 and a 2 and I multiply everything by 4, the 4 will cancel out and the 2 will cancel out. So let's multiply both sides of this equation. I can do it because it's an equation, times 4/1. Okay, so now I have 4/1 times negative 3/4 x plus, got to distribute, 4/1 times 1/2 y equals 4/1 times negative 1. So I just multiplied 4/1 times everything. So here the 4 will cancel out. I get negative 3x. 4 reduces to a 2 plus 2y equals 4 times negative 1 is negative 4. Okay, now we're working with an equation that has no fractions, right? Again, I want to isolate y to put this into slope-intercept form. To isolate y, I need to add 3x. 2y equals 3x minus 4. Divide everything by 2. I'm going to write it over here. Y equals 3/2 x. Negative 4 divided by 2 is minus 2. Okay, so we got them into slope-intercept form. The other part of our question here is also to find the slope and the intercept. So what is the slope for part A? And what is our B value? But also, what is our intercept? Notice how I wrote those separately. And then we'll do the same thing for part 2. I want you to try this on your own, and then we'll review it together. Okay, so our slope in the first one is 5/4, right? What number was multiplied to x? Our b value is -4. Make sure you have that negative there. -4. But our intercept is 0, -4. Be careful of that, right? Okay, part B, our slope now is 3/2. Our value for b is -2, but that's not our intercept. Our y-intercept, I should call it a y-intercept. Our y-intercept is 0, -2. The ordered pair is the intercept. Okay, we're almost done. Our last topic here is graphing linear equations. And the easiest way to graph a linear equation is to put it into slope-intercept form. Okay, and I'm going to show you why. So I'm going to take this, this equation here. It's not in slope-intercept form because y is not by itself. Remember, I want y equals mx plus b. I want y by itself. So how do I get y by itself? I have to add 2x to both sides. So y equals 2x plus 1. Okay, so why is this helpful? Well, I can say that my slope is 2 and my b value is 1. I'm not even going to find the y-intercept because I know where my y-intercept will be. It will be on my y-axis. And so I know that this point here at 0, 1 is my y-intercept. From there, I can use the slope. M is 2. That's the same as 2 over 1. Rise 2, run 1. So I go 2 up, 1 over. Now I'm going to keep doing that. 2 up, 1 over. 2 up, 1 over. Okay? Now why do I keep doing that? Well, I want this line to be straight. So if I can keep doing those points, then I can make my line go through all of those points. If you have a ruler, you only have to find 2 points and then you can draw your straight line with your ruler. If you don't have a ruler, what you're going to do is you're going to do as many points as you can and then draw as straight as you can through that. I will not dock points if it's not perfectly straight. However, if I see something that looks like this, that will lose points because that's not going through the correct points. Okay? If I see something that goes like, oh, I erased them. Let me see if I can undo that. Okay, sorry about that. So my straight line should go through all of those points. If I see something that starts curving this way, or maybe you go through one of the points and then you start curving, that will lose points. So you want your line as straight as possible. Now notice, I can also do the same thing the other way. If I went up to 1 to the right, then I can also go down to 1 to the left. That's equivalent to -2 divided by -1. Isn't that equal to 2 over 1? A negative divided by a negative is a positive. And so I can keep going, and I can keep going and keep going. And I'm going to label as many points as I can so that, again, my line can be as straight as possible. Doesn't have to be perfect, but it should be pretty close. Okay. Let's look at one more example here. Our last slide is a try this. I want you to try graphing this and then we'll look at it together. It's a little bit harder than the last one, but I know you can do it. Okay, so our first step, remember, is to put this into y-intercept form. So how am I going to do that? Well, I'm going to start by subtracting 4x from both sides because I need y by itself. So I have -7y equals -4x plus 14. Again, to get y by itself, I need to divide by -7, We saw this on the last slide, or on 2 slides ago, rather. So then y equals, now I have a negative divided by a negative, but I can't reduce it, right? So it's going to stay as 4/7 x. Here I have 14 divided by -7. That one does reduce to -2. My slope is rise 4, run 7. My y-intercept goes through a b value of -2. Okay, I'm going to switch colors just so you can see it a little better. So I start with my y-intercept, rise 4, run 7. Okay, now I can't do that again, right? I don't have enough space to rise 4 and run 7. I would run out of space. I only have 3 units there. So instead of doing that, let's go the other way. So we're going to go down 4, 1, 2, 3, 4, and then over 1, 2, 3, 4, 5, 6, 7. And I'm going to draw as straight of a line as I can. Doesn't have to be perfect. Through those points. Okay? And that's all there is to it. All right, so your homework is going to be, I'm going to go ahead and clear this off. Only, okay, there we go. Your homework is only number 1 through 4. If you'd like to challenge yourself, okay, this is a challenge. If you feel like you know this section, this is all review, then I'd like you to try to challenge yourself with the do you understand questions, especially with that error analysis. What went wrong with the error analysis? Okay, so I'm looking for number 1 through 4 from everybody. And if you feel like this was a review, try number 5 through 7.